know the Son, and know the Holy Spirit.
Amen.
Amen. Heavenly Father, King of glory, thank you for today. Thank you for the gift of life. Thank you for enabling us to attend this lesson, Father. Father, as you are going into the lesson, I pray that you enable us to understand everything that the chair is going to teach us. And may you bless him with the knowledge to grasp more and teach us. I've asked all of these and those requests deep down in our hearts. I pray that the Almighty Lord sees them. In Jesus' mighty name, as I've prayed and believed. Amen.
Amen.
In
In
the
the
name of
name
the
of the
Father, and
Father
of
and
the
of the
Son, and
Son
of
and
the
of
Holy
the Holy
Spirit.
Spirit. Amen.
Amen.
Thank you very much for that beautiful prayer that you have given us. Now, today we are going to look at X-rays, and you allow me to first of all share with you my screen, and then we can see exactly our working area and also our notes. So, those are the X-rays, and I think that's what you should do. Should also should have expected that we are going to look at X-rays. Now, members, what you should know is that these X-rays, these are not normal rays to us. We have seen light, and light we have studied about rays. So when someone talks about X-rays, someone may think we are talking about light rays. No, we are not talking about light rays, though X-rays and light rays have something in common, and they are all falling under the electromagnetic spectrum or the electromagnetic waves. So the X-rays, as you hear the word X-rays, those X-rays were discovered by just a certain gentleman that I've just forgotten right now. But that gentleman was called the Rudway. It was called the Cynthia. Let me ask Cynthia. Cynthia is one of the most active students. Cynthia. Cynthia, my daughter, X-rays were discovered by who? Sorry, I wanted to Google it, but I will not Google. But we are discovered by a certain gentleman, and this in 1908. I just forgotten the name. I will tell you the name when I remember it later on. And this gentleman discovered the X-rays by just, it was by mistake, first of all. It was by mistake to how he discovered these X-rays, and that's why they are called X-rays, because up to now, I think he failed to get the name and called them X-rays. The same way how we were doing mathematics, and you said, let us call this one X, and later on you find the value of X. So even him, he called these X-rays as X-rays, and later on said, yeah, I will find the name for those rays, but I think he did not get that, and now we named them as X-rays. So that gentleman was called, is it Hellsberg, something like that. And this gentleman, what he found out is that it was the hand of his wife, and the hand of his wife, one of the fingers had a ring. So the wife touched on a certain box where these X-rays were focused to, and what by that time they had developed photographic film. So what he discovered was that his finger or the lady's hand, they could see the bones, and also they could see the ring on her finger. So, and then later on they called these kind of rays as X-rays. Now, X-rays are used. X-rays are used in hospitals. That's what you should know. You shall get to know all that X-rays are used in hospitals. And now these X-rays, how they are produced is kind of so interesting, because remember that when you're looking at physics, when you're looking at this kind of nuclear physics, sorry, modern physics, we talked about the atom, and we said that the atom is the atom is made up of electrons, is made up of protons, made up of neutrons, and we say that electrons move around. So if this is the atom here, the atom has got a nucleus here, a nucleus, but inside the nucleus we have neutrons and their protons inside. So, but around it, we have what we call electrons, and electrons are moving. They are just moving around this, moving around. Now, in chemistry, also studied something like that, and you have electrons which are moving around the nucleus. So this is the nucleus, or the center, and the nucleus has a positive charge because that's where the protons are, and protons are positively charged, but electrons are negatively charged. Now, how are these X-rays produced? Now, that one is not in our notes. This one, they are talking about production of X-rays in an X-ray tube, but I want you to understand how X-rays are being produced in such a way that they are so different from light. You see light, how it is produced from these objects that keep on growing, but X-rays are produced whenever an electron shifts from one energy level to another. So there is energy that is emitted. This energy that is emitted can be emitted in form of a radiation. So normally the radiation that is emitted is a radiation of short wavelength. You understand that short wavelength later on when I'm talking about electromagnetic waves. So the wavelength is short, and because the wavelength is of short wavelength, then the frequency is too high. And this kind of waves that belong to that kind of category that have short wavelength and high frequency, one of them is the X-rays. So X-rays are produced whenever there is a shift of an electron, or there is a change of an electron from one energy level to another. The energy that is produced, that energy is in form of a radiation, and the radiation can be X-ray radiation, or the X-rays. Now, we have what we call the X-ray tube. The X-ray tube. So first of all, let us first understand, before we go to the X-ray tube, let us first understand what are X-rays. So X-rays, these are electromagnetic radiations. When I talk about electromagnetic waves radiation, so there are two terms there, electromagnetic. That's one term, electromagnetic, but there is one word, electro, and there is another word, magnetic, isn't it? Electro and magnetic. So those two words can mean something when it comes to electromagnetic radiation. I don't know, some people are not entering. Okay, hope they will enter. So it means that these electromagnetic waves or radiation, and one of them is the X-rays. These radiation have two fields. They have the electric fields. So they possess the electric fields. Now this term electric fields, question mark. Do you understand by the term fields? Members, are you there?
Yes.
So we have electric fields and magnetic fields. These electric fields and magnetic fields, once they are combined together, they form what we call the electromagnetic wave, or the electromagnetic radiation. And one of the electromagnetic radiation, one of them is the X-what?
Rays.
Is the X-rays. So X-rays have both electric fields and magnetic what? Have both electric fields and magnetic fields. Now, you know what a magnetic field is. Suppose if you get a magnet and bring it to another magnet, what will happen to those two magnets?
They will attract or repel.
Correct. They will attract or repel to each other, depending on the poles to which you are bringing those magnets to. So they will repel if the poles are of the same, or they will attract if the poles are unlike. So magnetic fields are always a magnetic field is just a region around a magnet where an electromagnetic force is experienced. Are we together? It is a region around a magnet where an electromagnetic force is experienced. So that is a magnetic field. And then the electric field, it is a region around, let me say, a region around a conductor. And this conductor is carrying current or is carrying electricity, region around a conductor where a force, an electric force, can I call it force, is experienced. So if conductors are carrying current, those conductors have a force in them. We shall look at that later, very later when we're looking at electromagnetism. So what you should know is that X-rays have both electric and magnetic fields, and that's why they are called electromagnetic fields, electromagnetic waves. Now, electromagnetic waves fall under the electromagnetic spectrum. And under the electromagnetic spectrum, we have different rays. We have the X-rays. We have the first one, which is known as the gamma what? The gamma rays. And we have also others. We have the visible light that we are seeing. We have the infrared. Before that, let me first write ultraviolet. There is ultraviolet. There is visible light. There is infrared. We are going to see all this. Now, some of these radiations, you cannot see them with your eyes. Number one, gamma rays, you cannot see them with your eyes. X-rays, you can't see them with your eyes. Ultraviolet, you may see them, you may not see them. Then visible light, that one you can see, the light that you are having right now in your house, that is visible light. That's why we call it visible light. Infrared, you cannot see it. We have what we call microwaves. And also we have what we call radio waves. So these are electromagnetic waves, all of them. But one of them that we are looking at right now, we are looking at We are looking at X-rays. So X-rays are part of the electromagnetic radiation of short wavelength. They are of short wavelength. They are produced when fast-moving electrons are suddenly stopped by a metal target. So in the X-ray tube, they are produced when fast-moving electrons are suddenly stopped by a metal target. Remember, someone can say they are produced when cathode rays are suddenly stopped by a metal target, because we said cathode rays are the fast-moving electrons. Are we together? So if someone says X-rays are produced when cathode rays are suddenly stopped by a metal target, that is correct. Or X-rays are produced when fast-moving electrons are suddenly stopped by a metal target. Now, there is a big process that happens during the production of X-rays. And we can say that this production of X-rays is an inverse of photoelectric emission. Remember, when we're looking at photoelectric emission, we said that this time it is a ray that is going to hit a metal and the metal produces electrons. That was photoelectric emission. That in photoelectric emission, a suitable radiation falls on a metal and the metal emits electrons. That was photoelectric emission. But in X-rays, they are now the electrons that hit the metal and the metal produces a radiation.
Yes.
Are we together?
Yes.
Yes. Kabami, are you there?
Yes, I'm there.
Okay. Are you following very well?
I'm trying to.
Okay. So I'm going to be a bit slow and clear to you that in photoelectric emission, I may not write notes because the notes you have in the handout, they are just enough. So in photoelectric emission, it is now the radiation. The radiation hits, so there must be a radiation, that is coming from somewhere, a radiation hits a metal. This is a metal, a suitable metal, and then this metal releases what we call electrons. It releases what we call electrons. So there are electrons that will be emitted from this metal after the radiation falling on that metal. That is photoelectric emission. But in X-rays, this time they are the electrons. So they are the electrons that are moving, or the cathode rays that are moving, and they hit a metal target. So if this is the metal target, they meet the metal target, and the end, after hitting the metal target, what we expect from here is the production of what? The production of Of X-rays. X-rays. So this time, once the electrons hit the metal target, the X-rays that are produced when you're looking at X-rays. Whereas in photoelectric emission, it is the radiation that hits the metal, and the electrons are produced. Electrons are emitted. Electrons are emitted. That's what we looked at first. Okay. Now, let us look at the production of X-rays in the tube. So before we look at this is the diagram that we are expected everyone to draw. This diagram, which is here, may zoom in there very well for you to see. This diagram, which is here, is what we expect everyone to draw if you are if you are going to do your exam and they have told you to write the production of X-rays. So you need to first draw the diagram first. This is the X-ray tube. This is the X-ray tube. Now, before we proceed into details, let me first show you the video of this X-rays, how they are being produced. So I want you to listen to this video very well and look at it very well, and then you understand. So in this video, they have made a simpler kind of tube. So this is now the kind of the tube there. It's called the college tube. It was just a design of the X-ray tube, just a different design of the X-ray tube, because we shall see later on what is needed for you to make an X-ray tube. Maybe you can also make one at home, but we shall see. Now, this X-ray tube, what it has here, it has what we call the cathode. This one here, this is what we call the cathode. And this is what we call the anode, this one. So this is the anode, this is the cathode. Now, inside the cathode, we have what we call a filament. So we have a tungsten filament inside. And this tungsten filament, its purpose or its function is to hit the cathode. And I would request, I'm going to ask someone, let me ask Letitia. Letitia, what's the use of the filament?
The filament, it's the cathode.
It is the cathode. And Sherry, I'm asking you, what happens when the cathode is heated?
It emits electrons.
Electrons, correct. Just stop there. It emits what? Okay. Electrons. That's correct. It emits electrons. So the filament is made of tungsten. Who can give me the reason why the filament is made of tungsten? Tungsten. Why do they use a filament? And this filament is not made from copper. The filament is not made from bronze. The filament is not made from gold. Even gold, which is very precious, they don't use it for making a filament, but they use tungsten. Which property does tungsten have such that they use tungsten as the metal used for manufacturing filament, the filament? Who knows that? Patricia, do you know? Yes. So, who knows? Yes, Patricia. Patricia? Yes. Yes, Patricia. So members, previously remember that the filament is made of tungsten, because tungsten has a property that it has the highest melting point, it has the highest melting point. So even if they hit the filament with some voltage, this filament will not melt because it has a highest melting point. Let's continue. So this is the anode, and the anode is this the target. So inside this bottle, inside this glass tube, or inside this glass tube, it's fine, you can unmute. So inside the glass tube, Patricia, inside the glass tube, the pressure is very low. So this is the pressure, 10 to the power negative 6 millimeters of mercury. That is the pressure. That means the pressure inside is very low. Why is the pressure is low? The pressure is low, or the tube is evacuated. Whenever you evacuate the tube, you reduce the pressure of the tube. That's what we looked at. Get a cavera and remove the air from that cavera. It means that cavera will collapse inwards, meaning that you have removed the air. It means that also you have reduced on the pressure that is inside that cavera. So even the tube, if the air is removed, the pressure of the tube reduces. So the pressure falls to 10 to the power negative 6 millimeters of mercury. Why is it evacuated? To prevent collisions of the electrons with the air particles. Okay. So how do we explain this? So we say that when the filament is heated, when the filament is heated with a low voltage. So once the filament is heated with a low voltage, the filament hits the cathode, and the cathode emits electrons. Now together. So these green ones are the electrons. Now you should know that the other thing is that the cathode is made concave such that all the electrons are focused onto the metal target. Yes, the cathode is made concave such that all the electrons emitted are focused onto the metal target. Now, the metal target is connected to the anode. And this anode is made up of a copper block. So once the electrons hit the metal target, there is heat that will be generated at the metal target. That makes the copper also to be very hot, very hot. So in most cases, there are copper fins that are connected to the anode, and water passes through the cooling, passes through the copper block, or passes through the cooling fins to take away the heat, to absorb the heat from the copper. Where does the heat come from? I've said that when the electrons hit the metal target, the target becomes so hot. And now the heat that is generated is carried away by the copper or the cooling fins. So inside here, this is the copper block. By the copper block inside here, we have cooling fins. So these cooling fins, their purpose is to take away the heat from the metal target, such that the X-ray tube, its temperature reduces. So what you should know is that when electrons are moving, they move with kinetic energy. All their kinetic energy, most of their kinetic energy, we say that 99% of their kinetic energy is converted into heat, and only 1% is converted into into X-rays. So when the electrons hit the metal target, almost 99% of their kinetic energy is converted into heat. And that heat is now taken by the cooling fins, and it is taken away from the X-ray tube. Then the other 1% of the kinetic energy, it is the only one that is converted into X-rays. So the X-rays, let me see. So what you should know is that the X-rays are produced whenever these electrons hit the metal target. So you see how the metal target is. It is at an angle 45, such that the X-rays that are produced from the metal target here, they are at an angle of 90 degrees. That's what I wanted you to see, that white thing. So if these are the X-rays, the ones which are here in white form, so these X-rays will be at an angle of 90 degrees from this point here. We shall see. I'm going to show you a video how an X-ray machine looks like in hospitals. Some of you have never seen one. So, but what I want you to know is that these electrons, they are fast moving electrons. And what makes them to be moving very fast? Number one, these electrons are negatively charged and they are attracted by the anode. And the anode is at a positive potential, this anode. The other thing is that what accelerates these electrons is the external voltage. So there is a high potential of 20 kilovolts connected between the anode. This is why you see there is current. That's why it is red. So there is current here. And also there is current connected to the cathode through this. So it means that when electrons are being generated or they are being emitted, these electrons, they are accelerated by a high voltage. That's what you should write in your notes, that the electrons emitted from the cathode are then accelerated by the high voltage. On hitting the metal target, 99% of their kinetic energy is converted into heat, which is carried away by the cooling fins. And only 1% of their kinetic energy is converted to X-what? To X-rays. Are we together?
Yes, teacher.
Yes, only 1% is converted to X-rays. And then you should note something and then say that the metal target, the X-ray tube, the X-ray tube is also evacuated to prevent the interactions of the electrons with the air particles, such that the electrons do not lose their kinetic energy to the air particles on collision. So if we have air particles here, electrons can collide with the air particles. Electrons can collide with them. So the only way how to prevent that is by removing the air, reducing on the pressure inside the tube. And once the pressure is reduced, then the X-rays are going to travel at a high speed. And this high speed is due to the high potential or the high, yes, the high potential. It's the one that accelerates the electrons towards the metal target. So in your notes, you can say that when the filament is heated, or you can say the filament is heated with a low voltage. You can see this battery, which is down here, is the battery used for heating a low voltage. This one here, for heating a filament, this one here. So this battery has a low voltage. So the filament is heated with a low voltage. The filament hits the cathode. The cathode emits electrons. Are we together?
Yes, teacher.
These electrons are accelerated by an external voltage towards the metal target. When electrons hit the metal target, 99% of their kinetic energy is converted into heat energy, which is taken away by the cooling fins.
Share too fast.
Yeah, I know. Those things are in the notes. Are we together? Are you writing? You
just noting down.
Okay. So they're in the notes, and also those notes are very clear, very clear. That's why I'm not writing today. They are very clear. The way they are, that's how you should write. So almost 99% of their kinetic energy is converted into heat energy, which is carried away by the cooling fins.
Fins.
Only 9% of their kinetic energy is converted to X what? To X-rays.
Only 1%.
Yes,
Wow.
1%.
This-
Of course, 100 minus 99, don't you get 1?
Yes.
Yes, only almost 1% of their kinetic energy is converted into X-rays. Then you add on and say that hey, Patricia, you don't know how to unmute yourself. Patricia, you are allowed to unmute yourself, please. I can't unmute you from this side. So the other thing is that the X-ray tube is evacuated to prevent interactions of the electrons with the air particles, so that electrons do not lose their kinetic energy to the air particles on collision. And then you have finished explaining what we call the X-rays. So let's continue the video and see.
Teacher. Excuse me,
So,
teacher.
yes.
Why is the cathode made out of copper?
Why is the cathode made out of what?
No, the anode. Why is the anode made out of copper?
Why is the anode made out of copper? So last time, I don't know if you remember very well when you're studying in senior 2 conductivity of heat. Do you remember when you're studying conductivity of heat? So copper has a property of conducting heat faster than other metals. So that's why they use it such that all the heat that is generated at the metal target is conducted away. Letitia, are we together?
Teacher,
Yes.
Yes.
at the X-rays, the rays they emit, are they like bad?
They're very dangerous, my dear.
Oh.
Very dangerous. We shall see one of the things that one of the safety precautions they take to prevent X-rays from entering into our bodies, and also we shall look at some of the hazards that X-rays bring if you are exposed to X-rays. Is there any other question? Okay, now, so always water. Here they are using water, but these are the X-rays. Very good. Let me pause there. So the intensity of the X-rays will depend on the number of electrons that are hitting the metal target. The intensity of X-rays will depend on the number of electrons hitting the metal target. And how do you increase on the number of electrons hitting the metal target? By increasing on the voltage that is hitting the cathode. If you increase on the voltage in the filament, remember the filament is the one that hits the cathode. So when you increase on the voltage that hits the filament, it means that the filament will hit the cathode and more electrons will be produced or will be emitted. So on increasing on the voltage hitting the cathode, more electrons are emitted. If more electrons are emitted, then the intensity of X-rays also increases. Are we together?
Yes, teacher.
So once the voltage has been increased, then also the intensity of X-rays will increase. So that's what I wanted you to see. So when we so these are the notes which are here, and they are trying to explain for you. They're saying the cathode is heated to emit electrons by thermionic emission using a low voltage supply, because that's what we looked at. We said thermionic emission is the emission of electrons when a metal is heated. Whenever a metal is heated, that's why we call it thermionic. So ionic means charge, then thermal means heat. So when you connect those two words together, heat and ion, you get the word thermionic. So charges, and these charges which are emitted are electrons, and they are emitted whenever a metal is heated. That's why we call it thermionic emission. And always the cathode must be heated with a low voltage. Even in the CRO, the cathode is heated with a low voltage. So the high PD is applied across the anode to accelerate the electrons towards the anode. That is it. When the cathode rays, now here they're talking about cathode rays, they're not saying electrons, but they mean the same thing. When the cathode rays or electrons strike the metal target, about 99% of their kinetic energy is converted